every diet book the same. I mean, they're all very similar. One of them say don't eat fats, another say eat fats. Say sugar is bad, another one say no, forget about it, the sugar is good. It's kind of confusing. Of myself, clinical nutritionist and a fitness coach, and I'm studying biochemistry. And when I start studying biochemistry, your book made more sense than all the books I have in the library.
Explain exactly what goes on with weight regulation, and it explains why the current strategies of chasing calories, running away from obesity in the gym, why it doesn't work long term. It works short term, but so I think it's an important book that really explains all of these factors: weight set point, leptin resistance.
I think your book is just amazing, and I think that's everyone have to read your book to understand more about dieting.
So nice to meet you, Albina. Nice to speak to you, and thanks for the interest in the book. I'm a bariatric surgeon, so that means I do surgery to help people with severe obesity lose weight. So quite extreme operations, removing or bypassing the stomach, and it's really popular surgery because it's really effective, and because it's like keyhole surgery, small little cuts, 5 small little cuts. It's not too painful, so recovery is fast. And for instance, you get someone who's maybe average 18 stone will go down to 11 stone after a year. So it's pretty effective surgery. But this is the thing that got me into an interest into weight regulation and obesity, because why would someone want to have that surgery if going on a diet and going to the gym really did work in the long term? It doesn't seem to work for most people. There's a lot of movie stars and pop singers and people who've had this surgery, but they don't admit to it. I mean, it's really clear when there's someone who suspiciously loses a lot of weight and keeps it off. And there are various politicians and pop stars, and I'm sure with a diet, that amount of weight loss is perfect for someone who's had bariatric surgery. That's exactly where they would get to, and it happens in a year. And it's a revolutionary change to their lives. And the problem is, it's almost perpetuating this shame of being obese by not admitting that you had the surgery, and the fact that the condition beforehand was a disease. It's a problem you can't get out of. If you read the book, it is a real problem with messaging from the fat cells to the brain, so the brain doesn't know how much fat's on board. So by not admitting, these sort of celebrities who have bariatric surgery, by not admitting that they've lost their weight through surgery, and by saying, I just went on a diet, they're shaming everyone else who can't lose weight on a diet. So it's perpetuating this sort of prejudice against people who are obese.
Why one contradict each other? Each study contradict each other, and that's confusing. And when I found you said about the calories, so I never seen anything like this. Can you explain how you count the calories, how you see calories?
So you sort of mentioned the brown and the white fat cells that were described in the book, and that sort of gets to the core of the explanation in the book to why we can't lose weight and keep weight off on a diet. And it's to do with this thing that we all burn off energy when we don't even move. So 70% of the amount of energy that we burn every day doesn't include movement. It includes heart rate, heating the body, chemical reactions within the body, that sort of thing. So we don't have any control over that. And so the conventional medical training is that if you calculate someone's height and their weight and their fat-free mass, you can sort of get an estimate of their metabolic, how much energy they're burning. But actually it's very, very variable, and the variability comes from things like the research into brown adipose tissue. So brown adipose tissue is something that's in mice and small mammals, and it's a type of fat that actually can heat up. It's like a little thermal heater. And so they can take in food energy, and when they're in a really cold environment, they can just use it to heat up these fat cells. And there's a lot of research now in humans that actually we can convert chemical energy into thermal energy in skeletal muscles in something called sarcolipin. And that explains why, again, you mentioned previously in our email correspondence why this whole problem that, we know that people eat 500 kilocalories more per day now than they did 30 years ago. We know as a population that happens. The research now shows that in humans, a similar type of brown adipose tissue that can be used to produce heat energy from chemical energy from food. So basically an ability to waste energy that's been uncovered. So this is from in our muscles. We can actually just waste energy if we want to, and this explains why, as a sort of human population over the last 30 years, we've been eating 500 kilocalories per day more than 30 years ago, but we haven't put on as much weight as would be predicted. So if someone eats 500 kilocalories per day, that's 3,500 kilocalories per week, which is a pound in weight gain as fat. Unless you're burning that off in the gym, and I don't see much evidence that over the last 30 years there's more exercise than 30 years ago. So that would suggest that someone would put on 2 pounds, so 1 pound a week, or 2 kilograms a kilogram every 2 weeks. So something like sort of 20-25 kilograms per year per person, per population. So this would be a massive obesity explosion, a massive and sudden obesity explosion, if there wasn't a process of burning off that extra energy. So our metabolism shift upwards and burn off energy when we overeat, and that explains why when we go on a diet, we lose a little bit of weight first, but then the metabolism shifts downwards and we just try and preserve energy. We turn down our internal engine massively. And so people who have been dieting throughout their lives will always say, oh yeah, I lose a bit of weight at first, and then despite maintaining the diet and maybe only being on 1,200 kilocalories a day, I stop losing weight. And it's because the body has adapted to the diet by not burning as many calories. Just as when we overeat, we don't put on as much weight as would be predicted. And that's the sort of crux of the book. And the shifts in metabolism downwards when we diet and upwards when we overeat, trying to protect us and maintain us in this weight set point. So this internal setting that the body wants us to be. So this is the amount of weight that our body thinks is healthy to our survival. And for some people that is set far too high, and the book goes into the reasons for that.
How possible is that, to put on weight in 4 days so quickly that you tried to work 6 months? And in I know it's water, it's salt, it's but mainly what you want, you crave carbohydrates. That's what you don't eat as much when you're training, because you want to keep lean. If you eat 1,500 calories for 2 months, then after a while that's not working for you, so you have to deduct. And then if you go back to, like, some of my clients, they say, okay, that's it, I don't want any more dieting, I'm going to eat 1,600 or 1,800 calories a day, and then they start putting on weight to the point where they stop putting on weight, but then they're not happy with their weight. They want to be lower. So
exactly. So they're on 1,600 calories. They're still hungry. And they're putting weight. And if they went to their GP and said, "Look, I'm really being careful. I'm only eating this. I'm on 1,600 calories a day," the GP would say, "No, I don't believe you. You're cheating on it." And the problem is that the research into metabolism is, it's out there. It's a little bit historical, but it's not really understood, or in doctors' consciousness. We're not trained into understanding that our metabolism can shift up and down.
You explain all about metabology in your book. Doctors who know what they're doing, but they have about this much knowledge about nutrition. I thought doctors should know a lot about nutrition, but they don't. They spend an hour or hour and a half, maximum 2 hours, in their 4 or 5 or 6 years of study being a doctor, and that's not enough.
Correct. If that, it's basically totally overlooked, and the understanding of weight gain and obesity amongst your normal doctor is the same as a tabloid newspaper reader. energy in and energy out, that sort of very simple energy balance equation, without any understanding that the energy out, the amount we burn, is not just the stuff we do in the gym and running for the bus. Actually, profoundly, the body can shift metabolism up and burn energy if it wants to, or down and save energy if it wants to. And that is the crucial thing that's misunderstood. Because it's so powerful and it can shift up and down by 700 kilocalories a day, which is the same as a 10k run or a large 3-course meal. Because it's so powerful, the question in the book is, why did human populations start to put weight on? Why, if we can adapt so well, why are a third of our populations obese? And so that's explained in the book there.
When you explain about why people should eat cooked food, raw food diet, and you said your daughter likes to cook, and you couldn't understand why she's constantly watching like all these famous chefs cooking.
I mean, people are interested in food, and as is explained in the book, it goes back to our sort of evolutionary basis. If we hadn't invented fire and the ability to cook and pre-digest food, then we wouldn't have had this metabolic room in order to develop our very energy hungry brains. So we have a much bigger brain than other primates, because we have actually a smaller GI tract, a smaller gut, because we cook food, we pre-digest, so we don't need to break down that food as much as we would if it was raw food. So we're able to have a smaller gut. So if you compare a human gut to a primate, so a monkey or a chimpanzee or a gorilla, it's much smaller and our brains are much bigger. So we have this very, very close relationship with cooking food because it made us human. It was a picture of a chimpanzee, a gorilla.
Yes. So do you think that because they start cooking, then the brain kind of start growing?
I mean, I think there's evidence that about 1 million years ago, Homo erectus started to, be able to use fire, and at the time also it was, going from the jungles to the savannas and hunting more successfully. Yeah. And so they were able to, eat a wider range of foods because they had fire. They were able to digest meat, and actually importantly tubers, which raw are probably not very palatable, but tubers, potatoes, things like that. They were able to cook those. From Homo erectus to Homo sapien, that's when we had this encephalization, or the growth in the human brain, until we get to 200,000 years ago.
None of the books I read explain that. That's why I thought, wow, that's really interesting.
This is why humans we've always had this relationship with cooking, not just eating raw food, like going out and either hunting and eating raw meat, but we've always had this profound relationship with collecting the food, cooking it and sharing it. And this sort of control over food has defined humanity, and it's gone from just simple cooking of hunter-gatherer foods to local market, to farming.